Hi friends, welcome back to my channel Complex to Simple once more. And today we'll do linear equations, that is from level 1, page number 3.5, conditions for solvability. Let me know if I would change my language for you, if it will be convenient for you if I speak in Hindi or any other else, because my periphery is small. I only know English and Hindi and Bengali. So do let me know. So today I'll just thank you, all of you, for my subscribers and the support you are providing me. So today let's start. I have copied the sum for you only. Let me read it out. Find the value of k for which this equation has a unique solution. Now for unique solution, we have to satisfy one condition, a1 by a2 not equals to b1 by b2. Okay, so a1 over here is 4 by a2 is 2 not equals to k by 2. Okay, so k not equals to 4. Okay, now any value of k will be accepted, but only 4 will be rejected. Okay, so any value of 4 will be accepted except 4. Okay, the second sum says find the value of k for which this equation has infinite solution. Now for infinite solution we have to satisfy this condition, a1 by a2 equals to b1 by b2 equals to c1 by c2. We will just make a slight change over here. We'll consider this as equation 1 and this as 2. Okay, so this is a1, this is b1 and this is c1. Okay, so we'll write k plus 2 into x plus 2k plus 1 into y minus 2k minus 1 equals to 0. So this is equation 1, and 2x plus 3y minus 2 equals to 0. So this is equation 2. Okay, so it is a1, it is a2, b1, b2, c1, c2. Okay, for your convenience I have written it down. Now k plus 2 by 2 equals to 2k plus 1 by 3 equals to 2 to k minus 1 by 2. Now this 2 and 2 will get cancelled. Okay, so from this part we can just write 3 into k plus 2 equals 2 into 2k plus 1. Okay, so now 3k plus 6 equals to 4k plus 2. So 4 equals to k, so the value of k will be 4. Okay, so this sum says find the value of k for which this equation has infinite solution. Actually I am doing these sums repeatedly because these sums came each and every time in your CBSE boards, like in 2003 2001, each and every time it came. So these kind of sums are very much important to you, so you have to solve it actually very quickly and very confidently. Okay, so we'll write down the equations. 2 into k plus 1 x plus 9y minus of 7k plus 1 equals to 0. Now kx plus 3y minus 2k plus 1 equals to 0. Okay, so which condition I have to follow? Actually I have to satisfy this one. Okay, for infinite solution this condition I have to satisfy. Okay, so now we can write 2 into k plus 1 by k equals to 3, because 9 divided by 3 is 3. So 2k plus 2 equals to 3k. So the value of k will be 2. Now we'll just see if it satisfies all of them. So 2 plus 1 is 3. 3 into 2 is 6. So 6 by 2 equals to 9 by 3 equals to 7 2s are 14. 14 plus 1 is 15. And 2 2s are 4. Okay, 5. So each and every one comes out to be 3. 6 by 2 is 3. 9 by 3 is 3. 15 by 5 is 3. So the value of k will be 2. This sum is very important to all of you. The next sum is find the value of k for which this equation has no solution. Now for no solution we have to satisfy a condition, that is a1 by a2 equals to b1 by b2 not equals to c1 by c2. Okay, so for this we have to write 12x plus ky minus 6 equals to 0. Now kx plus 3y minus of k minus 3 equals to 0. So from here we can write 12 by k equals to k by 3 not equals to 6 by k minus 3. Okay, so k square will be 36. This into this equals to k square. So the value of k square will be plus minus 6. Now we have to solve which value does it satisfy. Now if the value of k is 6, okay, positive 6, then 12 by 6 equals to 6 by 3 not equals to 6 by 6 minus 3. Okay, so this is half, no sorry, this is 2, this is 2, this is also 2. Okay, so 6 will not do, because if 6 will be taken, then this one will become 2, this one also will be 2, and this will be 2. So 2 cannot be taken, so we'll not take 6 as the value of k. Now we'll try minus 6. Okay, suppose 12 by minus 6 equals to minus 6 by 3, 6 by minus 9. Okay, this will do. Okay, this will do. So the value of k will be minus 6. You have to keep it in mind. These are the simple tricks you have to do or you have to perform while your exams. Okay, so the value of k will be negative 6. Positive 6 will be discarded. Okay, now prove that there is a value of c that is not equals to 0 for which the equations has infinitely many solutions. So for this we have to satisfy the condition a1 by a2 equals to b1 by b2 equals to c1 by c2. Okay, so now 6x plus 3y minus of c minus 3 equals to 0, 12x plus cy minus c equals to 0. This is equation 1, this is equation 2. Okay, so now we can write okay, so 6c equals to 36, value of c will be 6. So the value of c comes out here as 6. Now this part 3c equals to c square minus 3c. So 6c equals to c square. So 6c minus c square equals to 0. C will be taken as common. Okay, so value of c is 0 ones, 6 ones, but this value cannot be taken because it's mentioned there over the question that C cannot be 0. So the value of C will be 6. So we will write the answer over here. The value of C will be 6. It's clear to all of you? Now, determine the values of A and B so that the following system of linear equations have infinitely many solutions. These are the two given equations. I'll suggest you to try over there. Start in your copy. So, we have to satisfy one condition, that is for infinitely many solutions. So, A1 by A2 equals to B1 by B2 equals to C1 by C2. Okay. So 2A minus 1 by 3 equals to 3 by B minus 1 equals to 5 by 2. So we can write 2A minus 1 by 3 equals to 5 by 2. So 4A minus 2 equals to 15. So 4A equals to 17. So A equals to 17 by 4. I have a small request for you. Let me change the pen because it's not working properly. So I'll use the blue one. So the value of A is 17 by 4. Now it's turn for B. 3B minus 1 is to 5 by 2. Okay. So 5B minus 5 equals to 6. So 5B equals to 11. So the value of B is 11 by 5. Okay. So we can write the answer as A is 17 by 4 and B is 11 by 5. Is it clear to all of you? So the next question is, find the values of P and Q for which the following system of linear equations has infinite number of solutions. Okay. So for that, excuse me, A1 by A2 equals to B1 by B2 equals to C1 by C2. So let us name this equation as 1 and this as 2. Okay. So P plus Q by 2 equals to 2P minus Q by 3 equals to 3 into P plus Q plus 1 by 9. Okay. So P plus Q by 2 equals to P plus Q plus 1 by 3. So 2P plus 2Q equals to 2P plus 2Q plus 2. Actually it would be 3P 3Q. So it would be 3P minus 2P would be P plus 3Q minus 2Q would be Q equals to 2. And 2P minus Q by 3 equals to P plus Q plus 1 by 3. So 2P minus P will be P minus 2Q equals to 1. So from here we can find the value of P and Q respectively. So for that, 2P minus 4Q equals to 2. Again 2P plus 2Q equals to 4. So from here we'll subtract this. So minus 6 equals to minus 6Q equals to minus 2. So the value of q will be 1/3. So the value of q will be 1/3. Okay. Now the value of p plus 1/3 equals to 2. So p equals to 5/3. Okay. So we can write or conclude from this that value of p is 5/3 and value of q is 1/3. So here's your answer. Okay. Last but not the least, this is sum number 37, and I have already created a structure of this chapter to you, so it will be convenient for you when you practice these sums at home. So first, for which values of lambda do the pair of linear equations this have no solution, infinitely many solutions, a unique solution? Okay. So for no solution, we have to satisfy a1 by a2 equals to b1 by b2 not equals to c1 by c2. Okay. Now for infinitely many, a1 by a2 equals to b1 by b2 equals to c1 by c2. Okay. And now for unique solution, a1 by a2 not equals to b1 by b2. So these are the three conditions we have to satisfy for finding the value of lambda. Okay. So lambda square will be 1. Value of lambda will be plus minus 1. Now suppose we'll take the value of lambda as 1, so it will be 1 equals to 1 equals to 1. Okay. And if we take the value, so it will be not equals to, so okay, we cannot take the value of lambda as 1 in the first case, that is in no solution, because 1 1 1, it will give you 1, positive 1 positive 1 positive 1. So we'll try out negative 1. So in this case it will be negative 1 negative 1 positive 1, because negative 1 square will be 1. Okay. So you can take the value of lambda as negative 1 in this case. Okay. So in case number 1, that is no solution, the value of lambda will be minus 1. Okay. Now in the second case, okay, so in this case you can take lambda equals to 1 by lambda equals to lambda square. So in this case you can take actually both the values for lambda. It will be, if you take 1 1 and 1, you will get 1, and if you take, no, actually in the second case you cannot take negative 1. Okay, because if you take negative 1, it will become minus 1 and 1. So you have to take the value of lambda as 1. So over here the value of lambda will be 1. Okay. And now in this case we can understand that lambda will accept any value except positive negative 1. So we can write all real values of lambda except plus minus 1. So this is the end of the exercise, and I have a small suggestion for you. Do practice sums at home at least 1 to 2 hours every day if you are a beginner. And one more thing I'll suggest, to subscribe to Complex to Simple. Okay, goodbye.